ना कि दूसरी एक क्लास में इनके लिए रिकॉर्ड भी करता हूँ। आज मैं स्टार्ट करना भूल गया, लेकिन ये कि
ठीक है।
क्लास रिकॉर्ड भी होती है। तो अगर
ठीक
ये
है।
क्लास को इफ ही वांट्स टू हियर इट अगेन ही कैन ऑलवेज डू दैट। आई पुट द क्लास ऑन द यूट्यूब आल्सो। तो अगर
अच्छा
ये
अच्छा अच्छा।
तो वहां से डाउनलोड भी कर सकते हैं। मतलब नॉर्मल आजकल डिजिटल इतनी चीजें हो गई हैं कि उसके बहुत सारे फायदे हैं। अच्छा, जो
एग्जैक्टली।
स्टूडेंट्स के लिए सूटेबल फॉर्मेट है वो पीडीएफ है। ये जो
बिल्कुल
फाइल्स
ऐसे ही।
बेसिकली
जी जी।
स्मार्ट फाइल्स हैं। अब इसके लिए वो पूरा सॉफ्टवेयर भी चाहिए। सेकेंडली
ठीक है।
इसमें ये होता है कि दिस इज अ मिक्स फाइल। तो अब जो मैं इनको भेजूंगा, मैंने एक दो फाइलें भेजी हैं इनको,
ठीक है।
और इसमें इनके पास जो इनके लिए जरूरी है वो मैं कॉपी करा देता हूँ। एक्चुअली टाइम बहुत कम है ना, नाउ इट्स
बिल्कुल।
नवंबर। अब अगर हम बुक क्वेश्चंस इनको ज्यादा कराएंगे तो इसमें इनका लॉस है, क्योंकि अब
हाँ।
बुक क्वेश्चंस का नहीं बचा। थोड़ा सा
बिल्कुल।
ब्रिटेन में कम रिवाज है, इधर गल्फ में और कतर वगैरह में तो ये होता है इस वक्त सारे बच्चे सिर्फ टॉपिकल पास पेपर कर रहे होते हैं। अच्छा, अब
अच्छा अच्छा।
टॉपिकल पास पेपर थोड़े अवेलेबिलिटी में भी मसला है, ब्रिटेन में ना कम अवेलेबल है। जैसे
ठीक है।
हमारे पाकिस्तान में, सऊदी अरब में, कतर में ना पास पेपर की बुक्स मिल जाती हैं जो टॉपिकल होते हैं। अब जैसे
ठीक
ये
है।
ग्रेजुएशन कर रहे हैं, तो इनके पास एक बड़ी अच्छी बुक है जो इनके स्कूल ने दी है इनको। उसमें
बिल्कुल।
क्वेश्चंस हैं लेकिन वो थोड़े लिमिटेड है, उसमें ईयर नंबर नहीं है, वो मिक्स है, बुक क्वेश्चंस है और पास पेपर है। तो
अच्छा।
आपका जैसे बाहर निकलना होता है तो इफ यू कैन चेक कि अगर इनको कुछ कोई इस तरह की बुक्स मिल जाए जो एक, जैसे अब ये पेपर वन देंगे, पेपर टू देंगे,
जी जी
तो
जी।
वन की ना बनी हुई बुक्स आती हैं, वो बहुत अच्छी हैं इनके लिए। वो प्रिंटेड हो, डिजिटल ना हो। डिजिटल होती
ठीक
हैं तो
है।
बच्चे उसी पे सॉल्व कर देते हैं, फिर वो पेपर का इम्पैक्ट नहीं आता।
हाँ नहीं आता, बिल्कुल सही कह
तो
रहे हैं।
अगर ये चीज करे ना वो सबसे अच्छी है। बाकी मैं इनको अब ट्रांसफर करना शुरू कर दिए फाइल्स, और वो
ठीक है।
पीडीएफ। और इनके पास भी एक प्रिंटेड बुक है जो मैंने देखी है, बहुत अच्छी बुक, इनके स्कूल ने बड़ी अच्छी बुक कंपाइल की हुई है।
ठीक
और
है। चले।
कुछ कुछ बुक के हैं और कुछ इसके हैं, ठीक है ना। तो
चल।
स्टिल आई एम रिकॉर्डिंग ऑल्सो, और आई एम शेयरिंग माई नेसेसरी मटेरियल ऑल्सो।
ठीक है। और ये जो रिकॉर्डिंग है ये इसी पे ऑफलाइन जब हम इस मीटिंग पे जाके इधर से हम प्ले बैक कर सकते हैं,
हाँ,
ऐसा
अगर
ही है?
अगर अगर जूम पे देखना चाहें तो जूम पे देख सकते हैं। और अगर
ठीक है।
जूम जूम पे ये होता है कि टाइम लिमिट होता है, क्योंकि अब जूम का जो सेटअप है वो रिकॉर्डिंग एक दो दिन के बाद डिलीट कर देता है। यूट्यूब पे
अच्छा।
मैं, जो बच्चे मुझे कहते हैं मैं यूट्यूब पे डाल देता हूँ। यूट्यूब पे फॉर एवर पड़ी हुई है, और वो एक मरतबा बच्चा देखना चाहे देख ले, और अगर चाहे तो उसकी वो उस प्लेलिस्ट को लिंक कर ले तो फाइलें उसमें आती रहेंगी।
अच्छा, इसके वैद क्या होगा फिर उस पे है?
किसका?
वो ये हमारी ये जो वैद जो क्लास ले रहा है इसका
हाँ हाँ,
इसका
तो
लिंक।
अभी मैंने आज इससे बल्कि मैंने उबैद से पूछना था कि डू यू वांट, हर स्टूडेंट की अपनी एक स्टाइल होता है ना सर, हर
ठीक है।
स्टूडेंट का स्टाइल होता है। अगर ये कंफर्टेबल, क्योंकि ज़ाहिर है यूट्यूब में देखने के लिए अलग से टाइम चाहिए। सम स्टूडेंट्स, बिकॉज आई थिंक ही इज गुड इन पिकअप। सो अगर ये मैंने रिकॉर्डिंग करता हूँ और ये कहेगा तो आई कैन मेक अ प्लेलिस्ट देयर, एंड मैं इसको
ठीक
प्लेलिस्ट
है।
का लिंक दे दूंगा, उसमें फाइलें खुद ही आती रहेंगी बाद में भी, जब ये चाहे उस प्लेलिस्ट को लिंक करके उस
बिल्कुल,
दिन।
आप ऐसे यूट्यूब का लिंक मुझे भेज दीजिएगा ना, कर दें आप,
हाँ
ताकि
हाँ,
अगर जरूरत पड़े तो वी कैन रिवाइज इट।
बिल्कुल। उसमें ये होगा
ठीक है।
कि उस डेट वाइज देखेगा ना, तो
जी
मैं
जी।
जैसे आज फाइल अपलोड होती है तो मैं एक दिन में उसको कनेक्ट कर देता हूँ। तो
ठीक है।
ये कुछ स्टूडेंट्स ये करते हैं। कुछ स्टूडेंट्स कहते हैं कि भाई इस वक्त मेरी एडवाइस वैसे इस वक्त ये होती है नवंबर के एंड पे कि टॉपिकल पास पेपर ले लें, और हर टॉपिक के कम से कम 10-10 साल के पेपर करते जाएं, वो बहुत फर्क आ जाता है।
अच्छा।
मतलब जैसे अब ये टॉपिक है इंटीग्रेशन, ये खत्म हो रहा है, तो
जी।
इंटीग्रेशन के पास पेपर की कोई ऐसी बुक हो जिसमें ईयर वाइज क्वेश्चन लिखे हों, और ये करता जाए, उसमें से मार्क करे,
मैं
प्रॉब्लम्स देख।
वैसे, सॉरी मैं आपकी बात काट रहा हूँ, अब हमारे इधर तो कोई नहीं, मैं ज्यादा से ज्यादा प्रीवियस ए लेवल्स के पेपर्स डाउनलोड कर सकता हूँ।
हाँ, वो फिर दूसरा सोल्यूशन वही है कि इसकी कोई डिजिटल बुक हो। मैंने और भी जो मेरे पास ब्रिटेन के बच्चे हैं, मैंने देखा है कि यहाँ पर बुक्स अव्वल तो अवेलेबल नहीं है। अच्छा,
जी
अगर
हाँ।
वो अमेजोन वगैरह पे जाएं तो वो बहुत एक्सपेंसिव है, अननेसेसरी एक्सपेंसिव है।
हाँ हाँ हाँ।
उतने पैसों में तो हम खुद प्रिंट कर सकते हैं। तो
बिल्कुल।
अब ये है कि एक ऑप्शन यही है कि ये डिजिटल कुछ
नहीं,
फाइल।
मैं कहने ये लगा था कि आपके पास अगर कोई बुक्स है, मेरा मतलब है कि अगर आप जैसे आज ये टॉपिक आप कर रहे हैं, तो
हाँ
इसके
हाँ
अगर कोई 10-12 क्वेश्चंस का 15 का आप एक स्क्रीनशॉट लेके मुझे भेज दें आप,
हाँ हाँ,
तो
वो तो
मैं
वो
इसको
तो
मैं
बिल्कुल।
प्रिंट आउट लेके इसको दे दूंगा कि ये करना आपने।
हाँ हाँ
और मैं
बिल्कुल,
आकर
ये तो ऑप्शन है, बल्कि उसमें फिर ये भी
जी,
ऑप्शन है कि उसमें
उस
आपकी भी एफर्ट कम है कि ये जो मैं इसको डिजिटल डिजिटल फाइल भेजूं, ये उस
जी,
पर ही अपनी टैबलेट पे सॉल्व करके मुझे वापस भेज दे, वो बहुत जल्दी हो जाएगा।
बिल्कुल,
उसमें तो बहुत टाइम सेविंग भी है, पेपर सेविंग भी है। अगर हमें बुक
बिल्कुल
नहीं
ठीक।
मिलती और मुझे पता है मुश्किल है वहां, तो हम ये कर
जी, जी,
लेते हैं कि मैं इनको फाइल्स भेजूंगा, मैं आपको ग्रुप पे तो आप हैं, और इनको
बिल्कुल,
वैसे उबैद इज फॉलोइंग ऑब्वियसली, तो ये उसी पर सॉल्व करे और सॉल्व करके सेव करके पीडीएफ मुझे वापस भेज दे, या अगर क्यूरीज हैं तो वो ऑन स्क्रीन डिस्कस, उसमें टाइम बहुत बच जाएगा।
ठीक है,
ठीक है
बिल्कुल
ना?
ठीक है।
ठीक है।
चलें ठीक है।
ओके।
ओके, थैंक यू, अस्सलाम वालेकुम। वेट, यू कंटिन्यू।
नाउ उबैद, आर यू बैक हियर?
Yeah,
Okay, can you see the power now? Have you copy? Could you copy this first rule?
Yeah, I copied it.
Now this is the power of square. One bracket is powered. Now if the power is 3, should we, if the power is 3, will we go more than that? Look at A, B, C, D. So when there is a power, we extend it. We extend the brackets. The first bracket, the first box is up to C. No need to copy the second one. Can you tell me why it has been extended to D?
Because the bracket is cubed.
Yes, very good. So you got the point. Now look at this example. No need to copy it. Just look at carefully. X minus 2 appears once. X minus 3, then x minus 3 whole square. It means when you come across a powered bracket, you will actually go through a gradual increase in power. Power is 1, then power is 2. Now, I'm putting a question here. You can tell me, because you know this method. So you just help me out as you were doing with the previous question. Is it rule number 2 example?
It is, yeah.
Good. It's a whole square. Okay. Now I'm going to write it in bracket form and you have to tell me. Now this is the bracket form. You need to check that how I can solve it further. First thing I did, I made the bracket plus 1. I made the first bracket plus 1 equal to 0. Then what should I do next?
Then
See the
you,
working? Hmm.
yeah. Then you work out you make the other x equal to 0.
Yes.
And
But all I have taken x plus 1, 0. I have taken x minus 1, 0. I got A and I got C. Okay, just look at the solution for time saving. Now I have two brackets. I use them, x plus 1, x minus 1. And I got C, I got A. How can I get B now?
you substitute in the values for a and c, and then you make the rest x is equal to 0.
And you can find it by the solving. Two methods can be used to find B. Suppose any value of x. Normally teachers do not recommend it. Even I do not recommend it, but it's a very powerful method. Even it's a very quick method. Second, as you said, comparing, solving. Now, what is the suppose any value of x? It's a very interesting method that if you want to get a, you can put any value. You have the value of a, you have the value of c, put any value of x, any value, and you can put it back with the function. And suppose I am taking 0, so I can get the value of b. Even though this method is not a very official method, but it can save a lot of time. This is called a sideways method. Now, the actual method is very challenging, very expanding, but it gives a very good practice of algebra. Can you see what I have done? I have the value of A, I have the value of C. Can you see what I'm doing? Do you remember the topic remainder and factor theorem?
Yes.
Okay. And do you remember the method comparing the coefficient full expansion? Then you can compare.
Yeah.
So can you tell me what's going on here?
So what you've done is you've opened up all of the brackets.
and then you compare.
Yeah.
And after comparison, look at the comparison. We got equations.
Oh, yes.
And do you remember this comparison?
No, I've never done this. I've never learned this way before.
Oh, acha. Then what method you have done? By substituting, putting back A, B, C.
Yeah, you put back in ABC and then like generally,
Oh,
obviously,
but I have a doubt because I think you have done something of it. Maybe not this way, but you must have, because you people must have done remainder and factor chapter where you want to compare. But anyways, I do not want to introduce a new method at this time, and this will be an extra. It's not difficult, but it will be an extra thing to follow. Now, this is the method when we talk about the rule number 2. Rule number 3 is coming. 1 upon x plus a, x square plus b, a upon x plus a plus bx plus c. This happens when there is a power on x. Rule number 3. So can you copy now rule number 3?
yeah, okay. Yeah, okay, done.
Right. So can you see there is a power on x, separate power on
Yes.
x?
Yes.
There is a separate power on x. For example, 2 upon x plus 2, x square minus 3, a upon x plus 2, bx plus 3, x square minus 3. So now look at this question, and I cannot factorize it because x square plus 2 is not a factorable function. So I have to use rule number 3. Rule number 3 is a case when you have to solve directly and you have to break it in terms. Now look at this one.
Yeah, okay.
Have you done any question like this before?
Yeah.
Okay. Then again, we will be having that stop junction here, that we will take 1x equal to 0. We got a is equal to 3 upon 2. Then how we can find the second function? I have used the method of expansion and comparing. Now you can see here that we have unknown. We do not know A, we do not know B, we do not know C, and we have to find it by, we need to find the B and C. Now there are two unknowns. We cannot switch back because the unknowns are two. A is there, but B is not there. C is also not there. This method is called expansion method. You expand the function and now you can compare it, because look on the left hand side, it's 1x square, and here it is a plus b x square. So if you compare it, you can find the value of a plus b is equal to 1. Cx. On the other side, it's 0x. Then it is 2a and it is 3. So you can compare. This method is very easy and it is actually a pure algebra method. When you compare, you can get the value of C, you can get the value of B. But I will see if we can somehow bypass, and I will see the solutions. You must have some working of your school, how they were doing remainder factor in such a question. Rule number 4. No method of partial fraction can be applied if the given fraction is improper. What is an improper fraction?
When the numerator is bigger than the denominator.
Yes. If fraction is a fraction is improper if either the power of x is equal in denominator and numerator, or the power of x in numerator is greater. This is a special rule which doesn't apply every time. This is rule number 4. So you have to copy this. I'm just coming, copy this.
Okay.
Now, these are the examples of rule number 4. Rule number 4 is not always there. X square plus upon x square plus 1. These are the cases which you should never try to put partial directly because they are improper. So what you should first try to convert them to proper fraction by any division method. So, Ubaid, do you remember how to do long division?
Yes.
Good. So this is the function, this is the case. So this is rule number 4 extension. If you find a question in this form, you should first try to convert it into into proper fraction. Now, this is the case. Okay, now you have to see this example. I'm taking an example on the left-hand side. I have x square, x square upon x square plus 1. So how can I divide it? Can you copy the left-hand side column? Now, can you tell me how to do this division?
You divide the first term, which is x
Sorry,
squared,
I
with x
missed it.
squared, and that is 1.
What did you say?
You divide the first terms together, and that's x squared divided with x squared, and that is 1.
Right. And so I will take I will take 1 as my divider.
Yeah.
And then what should I do then?
Then you subtract it with x squared multiplied with 1.
And you change the sign and you get
Yeah.
-1 as remainder.
Yeah.
Good. Now, can you tell me how to write, how I can write the final form? How can I write a fraction like this? First copy this. First copy
Yeah,
this.
okay.
Then let me know how can I write down the fraction.
Yeah, copied it.
Right. So now can you tell me how can I write down the fraction in the final form? Suppose that now I take an example here and I say I want to divide 5 by 3. I'm taking a number to make a concept. So I write 5 inside, 3 outside. I say 3 times 1 and 2 is my remainder. Now, how should I write it? Do you remember how we used to write 1 whole 2 upon 3? Is it right? Yes, Ubed, can you hear me?
Yeah, I said yes.
Okay, I'm not able to hear you properly, but it's 1 whole 2 upon 3. It can be written as 1 plus 2 upon 3. 1 is the quotient and 2 is the remainder and 3 is the divider. So we have a rule, divider plus remainder upon, no, sorry. I will say that it is quotient plus remainder upon divider. So can you remember this rule now? How we can write a mixed fraction?
Yeah,
This
okay.
is a mixed fraction, and when you deal with a mixed fraction, you have to follow this method. Now, remember this rule, this one, and write how we write it, then remember this also.
Right,
So,
okay.
you have to copy the right-hand column, 1 minus 1 upon x squared plus 1.
Yeah, copied.
Okay, your voice is being actually a bit lag is coming somehow, but now I can hear you. This is the idea of doing partial fractions. So if improper fraction is given, first convert it into proper fraction, then apply the rules of partial fraction if required. Sometimes after division, the question becomes ready and there is no need for any further partial fraction treatment in that question. But if needed, you can apply the rule of partial fraction. Now, give a new heading, integration by partial fraction. Give the heading.
Yeah, okay.
Integration by partial fraction. I'm sorry, I'm not able to hear you properly. The voice is cutting a lot. Somehow there is a lot of lag coming. I don't know why, but a lot of lag is coming.
Is this better?
It's much better. Somehow
Right, okay.
voice was being cut, so
Okay, I think I've sorted it now.
oh, that's good. Now, these are, this is an AQA paper and this is a sample paper here. And have you seen this paper pattern in your school, this AQA brand, the 73573 mode?
Who-
Because I asked you to confirm from the school what syllabus code they are giving. It's very important for us. So we can, normally the papers are slightly different. One or two codes are there. And look, this is the syllabus 7357 code.
Right, so do you want me to ask my teachers for the specific code?
Or I can send you this file or send you the title page and you can ask your teacher that is it the syllabus we are following? Because it's better because it's an international system like Edexcel, like Cambridge, like AQA, they all are international systems. And
Okay.
sometimes the one school is following one code and the code is different. With the change in code, paper pattern slightly changes. After the class, I will try to send you this syllabus title page and also the title page of a paper. So you can compare them and you can ask your teacher that are these the papers we should try? Okay.
Okay.
Integration by partial fraction. If the denominator contains factors or it can be factorized, we apply integration by partial fraction. In this method, we first make the partial fractions and today we have discussed them. Normally, after applying partial fractions, normally we get a chance of using ln and then we get ln, we integrate. You have to copy this screen after giving the heading.
Okay. Right, okay, done.
So we have this concept here. I'm putting a question and I'm taking a simple question. And this question is showing that it is 2 upon x into x plus 1. And you can say there are factors in the denominator. When denominator contain factors, you should try integration by partial fraction. No need to copy this exercise number. These are just like a book reference. So just copy the question with the hint. Okay, let's start this question. First, apply partial fraction to get ready the question. Can you hear me, Beth?
Yes, I can hear you.
So can you start the question? 2 upon x into x plus 1.
So you uh write it as a partial fraction first.
Yes. You first write down the question as partial fraction, find the values of a and b, and then put them back. And then in the end, you will be doing the integration.
Yes.
So look at the steps, try to do it.
Right, okay.
So I'm getting a as 2 and b is minus 2. If I put them back, and then do the integration, are you getting the same values of a and b?
Yeah, I got the same as you.
And then if I put them back,
And then you put them back, you get 2 over x minus 2 over x plus 1.
yes, good. And then you can use ln method.
Yeah. Then you get ln x Yep, we got the same answer.
Good. Now, this is a chance of doing an improper fraction. So please copy this question.
Okay.
How I know that it is an improper fraction? The power of x is equal in numerator and denominator. So I have to first go for long division.
Yes.
So I got the long division step. So you please do this step with me. If you have any query, you can ask.
So will it be 1 minus 1 over x plus 1?
Yes, very good. And then you put it in the function
Yeah.
to integrate.
Yes. Same answer.
Good. So this topic is, mashallah, complete. This integration main topic is complete. And now I give you a very simple question, but in paper, questions can come difficult and simple both. Now copy this question and tell me how we can do this.
You can just split it up into x over x plus x over 4.
Yes, very good. And then we split it and we simplify it.
Yeah. Simplify it. So x over x will be 1. 4 over x. So and then integrate. 1 will be x. 4 over x will be 4 ln x plus c. And then the 4 you can bring into a power ln x to the power of 4.
Good. Now you have done trigonometry. So have you learned all the formulas of trigonometry?
Yes.
So just like these type of questions which we need when we are solving trigonometry, this is something which is now remaining, and then we can complete our integration. In the final part of integration, these type of questions are there. Like
Okay.
here, prove the identity sine 2x upon 1 plus 10 squared x and 2 sine x cos cube x. Right now, I want you to recall that how we convert sine 2 theta into normal angle?
Sorry, can you say that last bit one more time? You
Uh,
cut off.
Let me write here first, and then I can ask you what are the formulas for double angle? Sine 2
The
theta.
formula is that's 2 sine theta cos theta.
Okay, good. And what about cos 2 theta?
Cos 2 theta. Is it wasn't sure about that one. There's 3 for cos 2 theta, isn't there?
Yes, very good. Memory is working. That's very good. And then were these some formulas?
Yeah.
So please copy them again, because now we need them for integration final thing.
Yeah, copied.
Good. Cos 2 theta is equal to 1 minus 2 sine square theta. I move it here. 2 sine square theta is equal to 1 minus cos 2 theta. So sine square theta is a new formula, is 1 minus cos 2 theta upon 2.
Yeah, okay.
You please copy this also.
Okay, copied.
Good. And similar formula I will make now. Look at this.
Okay.
These formulas are needed for our coming work, which will be the last thing in integration. Integration is important, so we did it in a very proper pace. We did all the functions, but definitely the main thing is still remaining, the past paper practice. I want to recall log rules with you. When there is a division, it will turn into subtraction. So please copy this box also. Have you copied it?
Yes. Yes, I
Okay.
have.
Good. So you have now the formulas, our integration. I will share you, inshallah, a worksheet for our present work. And you can also use the school book you have. You must have a section of integration by partial. So together we can do some questions. So we can have a grip there. But I prefer questions which are now from the past paper. Okay. So we'll stop here. We'll continue, inshallah, in the next class. Thank you.
Okay, thank you, Hafiz.
Hafiz.